Welcome back to our class. Today we will continue our exercises. Exercise number 9. What are the specific volume, internal energy, enthalpy and entropy of steam at 1.50 megapascal and 254 degrees Celsius? First step in solving this problem is to identify the state of the steam, whether wet, dry or superheated. Using the steam table and using the technique of our previous exercises in identifying the state of the steam. At 1.5 megapascal, the saturation temperature is 198 degrees Celsius. Therefore, the steam is superheated since the given temperature is greater than the saturated temperature. Since the steam is superheated, to find the other properties of steam, we will use table 3 of steam table. These are the values we can get. Using interpolation, we can solve the volume, internal energy, enthalpy and entropy at 254 degrees Celsius. Exercise number 10. At 250 degrees Celsius, a mixture of saturated steam and liquid water exists in equilibrium. If the specific volume of the mixture is 0.04159 meter cubed per kilogram, calculate the following. Letter A, percent moisture, letter B, enthalpy and letter C, entropy. The problem stated that the state of the steam is wet mixture. To be sure, you can still check the state of steam by checking the saturated volume of 250 degrees Celsius. Using steam table at 250 degrees Celsius, you can get these values. Before solving the percent moisture, we will solve first equality by using this formula. Substituting the value of the volumes, then we can solve the value of X or quality. For letter A, finding percent moisture, we will use the formula X plus Y equal to 1. Transpose X to the right side, we can have this Y equal to 1 minus X, substituting the value of X of 0.8253. We can solve Y, which is equal to 0.1747 or 17.47%. For letter B, finding the enthalpy, we will use the formula. Substitute the value of HF, X and XHFG, then solve for H. So, the value of enthalpy is equal to 2501.7 kilojoule per kilogram. For letter C, finding entropy, we will this formula. Substitute the value of SF, X and SFG, then solve for S. The value of entropy is equal to 5.4998 kilojoule per kilogram Kelvin. Exercise number 11. Steam at a pressure of 0.90 megapascals has an entropy of 4.9678 kilojoule per kilogram Kelvin. What are the specific volume, internal energy and enthalpy? By using steam table, checking the saturated entropy of 0.9 megapascals. The entropy of saturated vapor at a pressure of 0.9 megapascal is 6.6191 kilojoule per kilogram Kelvin. Therefore, steam with an entropy of 4.9678 kilojoule per kilogram is a wet mixture. At 0.9 megapascals, we can get these values. Solving for X or quality, we will use this formula. Substitute the values of entropies. Then, solve for X. We have 0.6345 quality. To find volume of the problem, use the formula VF plus X VFG. Substitute the values of VF, X and VFG. Then solve the V, we have 0.1368 meter cubed per kilogram. To find the internal energy of the problem, use the formula UF plus X UFG. Substitute the value of UF, X and UFG. Then, solve for U, we have 1908.4 kilojoule per kilogram. To find the enthalpy of the problem, use the formula HF plus XHFG. Substitute the value of HF, X and HFG. Then, solve for H, we have 2031.6 kilojoule per kilogram. Exercise number 12. Steam at a temperature of 300 degrees Celsius has a specific volume of 0.09765 meter cubed per kilogram. Determine the pressure, specific internal energy, enthalpy and entropy. Using steam table, checking the specific volume of 300 degrees Celsius. The saturated volume of 300 degrees Celsius is 0.021669 meter cubed per kilogram. Since the specific volume, 0.09765 meter cubed per kilogram, is greater than the specific volume of saturated steam, 0.021669 meter cubed per kilogram, at 300 degrees Celsius, therefore, the steam is superheated. Using steam table, at 300 degrees Celsius, table 3. We can get these values. Using interpolation, we can solve the value of pressure, which is 2.53 megapascals, internal energy of 2760.9 kilojoule per kilogram, enthalpy of 3007.9 kilojoule per kilogram, and entropy of 6.6371 kilojoule per kilogram Kelvin. Exercise number 13. A 0.0856 meter cube drum contains saturated water and saturated vapor at 370 degrees Celsius. Letter A, find the mass of each if their volumes are equal. What is the quality? Letter B, find the volume occupied by each if their masses are equal. The first step to solve this problem is to draw a drum and label what is stated in the problem. We will let VV is the volume of saturated vapor, VL is the volume of saturated liquid, MV is the mass of saturated vapor, and ML the mass of saturated liquid. By using steam table at 370 degrees Celsius, we get saturated specific volume of 0.004925 meter cube per kilograms and liquid specific volume of 0.002213 meter cube per kilograms. Solving for letter A, find the masses if their volumes are equal. Since the volume are equal, we can directly divide the volume into half, so we have 0.0428 meter cube. Using unit analysis, we can formulate this formula. Mass of vapor is equal to the quotient of the volume of vapor and the saturated specific volume. So, we have 8.69 kg of vapor. For mass of liquid, same concept from mass of vapor, so we have the value of 19.34 kg. To solve XOR quality, use the formula. Quality is equal to the quotient of the mass of vapor and mass of the mixture. Thus, quality is equal to 0.31 or 31%. Solving for letter B, given that masses are equal, we can get also this relation, that sum of the volume of the vapor and liquids is equal to 0.0856 meter cube. Using unit analysis, same as letter A solution, in finding the mass of vapor. Thus, we have volume of the vapor is equal to the product of mass of vapor and the specific saturated volume of the vapor. Also for volume of liquid is equal to the product of mass of liquid and the specific volume of the liquid. Substituting volume of the vapor and volume of the liquid to our relation, volume of the vapor and liquid is equal to 0.0856 meter cube. Thus, we can solve the masses of vapor and liquid, which is equal to 11.99 kilogram. Substituting our masses to the previous equation, volume of the vapor is equal to the product of mass of vapor and the specific saturated vapor, and the volume of liquid is equal to the product of mass of liquid and the specific liquid. Therefore, the volume of the vapor is equal to 0.05905 and the volume of liquid is equal to 0.02553 meter cube. Exercise number 14. Steadily flowing streams of steam A and B meet and mix, then flow in a steady state in a pipe C, all under adiabatic conditions. Steam A is at 5.5 megapascal, 370 degrees Celsius and flows at 160 kilograms per second. Steam B is saturated vapor at 5.5 megapascal and flows at 160 kilogram per second. Letter A, determine the state of mixture C if change in kinetic and potential energy is approximately 0. Letter B, if the speed of the fluid in C is 30 meter per second, what is the pipe diameter? The first step to solve this problem is to draw situation of the pipes and label it with the given data. At pipe A, it has a pressure of 5.5 megapascal, temperature of 370 degrees Celsius, and a mass flow rate of 45 kilogram per second. At pipe B, the steam is saturated vapor, pressure of 5.5 megapascal, and has a mass flow rate of 160 kilogram per second. At pipe A, the condition of the steam is superheated since the given temperature is higher than the saturated temperature. Using steam table, the enthalpy at 5.5 megapascal and 370 degrees Celsius is 3109.6 kilojoule per kilogram. For pipe B, the enthalpy at 5.5 megapascal is equal to the saturated enthalpy of 5.5 megapascal, which is 2789.65 kilojoule per kilogram. Solving letter A question, since the pressure at pipe A and B are same, thus pipe C follow the same pressure of 5.5 megapascal. Using the law of conservation of mass entering is equal to mass out. Thus, mass A plus mass B is equal to mass C, which equal to 205 kg per second. Using the first of thermodynamics, also called as law of conservation of energy, stated the energy entering is equal to energy out. Thus, energy of pipe A and pipe B is equal to energy of pipe C. Since the potential and kinetic energy of system approximately 0. The remaining energy will be internal and workflow energy, which is also equal to enthalpy energy. Thus, the sum of enthalpy of pipe A and B is equal to enthalpy of pipe C. Using the equation, MAHA plus MBHB is equal to MCHC, substituting the known value, we can solve enthalpy of pipe C, which is equal to 2859.88 kJ per kilogram. Comparing the enthalpy of pipe C to the saturated enthalpy of 5.5 megapascal, the enthalpy of pipe C is higher than saturated enthalpy at 5.5 megapascal, which mean the steam at pipe C is superheated. For letter B, using steam table at 5.5 megapascal pressure and 2859.88 kJ per kilogram enthalpy, we can get the specific volume at pipe C, which is 0.03849 meter cube per kilogram, by using interpolation of the values as shown in the video. Using the mass flow rate formula, which is mass flow rate at pipe C is equal to the quotient of the product of area and velocity and specific volume at pipe C, we can solve the area of the pipe C, substituting the value of the mass of flow rate, velocity and specific volume at pipe C. Thus, area at pipe C is equal to 0.02630 meters square. To solve the diameter of the pipe, we will use the formula of a round pipe. Thus, the diameter of pipe C is equal to 0.183 meters.